So in this, we're going to look at the whole experiment for standardizing our sodium thiosulfate. So at the university and in class, we provide it for you already. And we're telling you that it's about 0.1 moles per litre. But we need to know this. We need it to 3 significant figures for it to be any use in our experiments. So that's what we're doing for our first experiment. The really nice thing is, the same experiment with vitamin C added into our conical flasks will be your internal. So that's quite handy. It's the same experiment, same observations. I'm going to run just one. I've got 3 conical flasks here because it's a good habit, but I'm only going to do one titer with you, otherwise the video gets too long. So the first thing for you to know is what's going on in each stage. So in our conical flasks, I've taken this cleaned out with distilled water to the electronic scales and put at least 1 gram of potassium iodide into there to give me lots of iodide ions, because in the balanced equation it's a 5-to-1 ratio with my standard solution. So in here I've got at least my 5 iodides, but I also want extra iodide because iodide helps the product iodine dissolve in water, because technically this is non-polar, so the iodide helps it dissolve. I'm going to add 20 mils, exactly 20 mils of potassium iodate to that, and when I do, nothing will happen. That's good, by the way. Nothing will happen. We want to get those crystals dissolved in that before we do the last step. And then once I've got that, I'm going to add my H2SO4, which it can just be done with a measuring cylinder, 10 mils of that, and start titrating immediately. And it doesn't have to be 10 mils, it's about 10 mils. If I overshoot, it doesn't matter. That's a bit rough. 5 mils is actually enough to have your 6 H+ ions by mole ratio. Okay, for the concentration we're using, 10 definitely covers it. So nothing will happen until I put those in, because this reaction can't happen without the H+. It's needed for one of the products. But what I want to do is just look at the maths behind that before I do the pipetting, because that's one of the slow tasks. For the group that I'm going to use, theirs is 0.0251 moles per litre. That's what they made for their potassium iodate. That's their solution. We're going to pipette 20 mils, so that's 0.0200 litres, 3 significant figures. So we're noticing 3SF, 3SF. So when I do that, N equals C times V, I get 5.02, 3SF again, times 10 to the negative 4 moles. When I look at my equation, 1 iodate makes 3 iodines. So I need to multiply by 3 to find the amount, how many moles of iodine are actually going to be in that conical flask when I've done this step. Once I've added my H+. There's nothing there until I add the H+, the sulfuric acid. So I do that, and to 3 significant figures, because that's not exactly what the value is, to 3 significant figures it is 1.51 times 10 to the negative 3. Within the precision of our equipment, we don't know it any further than that. We only know it to 3SF. So don't report your answers to more, because they're wrong. We're not that precise. We're precise, but we're not precise to a 4th significant figure. So now I know how much of that is. I'm going to end up doing a titration until all of that has been used up in a reaction with sodium thiosulfate. So I'm just going to get that set up. I haven't got my pipette ready yet, so just bear with me on that. And for speed, I'm not going to rinse it because they were used yesterday for these solutions, but you would rinse it with your solution, right? Because this is a demo, I'm just trying to get into it and check where our group is that's doing this one. Do you know what we wrote on it, team?
It's in black Sharpie. Yeah, that one.
That's the one. Cool, and thank you for letting me use that. So we're going to pipette this out. We would, of course, rinse it with some of this first, which means I'm not going to let any of this fall back in. In fact, I am going to rinse it because my own perfectionism won't allow me to not do it. And that means I won't contaminate your solution as well, so thank you for that. Okay, so I'll get my exactly 20 mils. I'm going to get my conical flask nearby so that I don't have any issues with the transfer. really putting this so low, wasn't it? I have to get down on the ground. Okay, and I think a lot of you are using the wheels to do this, so I'm going to do it the way you probably would. Above the liquid solution. And hoping like we can get this right on the line. There we are. And then use the trigger. Okay, now if there was already acid in this, it would start going brown from making iodine. That would be a bad thing. We want to make the iodine just moments before we start the titration. And the reason for that is the iodine will evaporate out of here. So you want it to start reacting with sodium thiosulfate as fast as possible. So you want to start the titration as soon as you've got the iodine in there. Remember, when you've touched that to the side, you want to wash the walls down with a bit of distilled water. So make sure you've got every mole of that in there. Now I'm just going to swirl it until that iodide has dissolved. So a couple of crystals, so I'll just keep going. I want every bit of that iodide dissolved. Cool. I don't want it affecting my results. That's one of our gin cupboard telling me it doesn't like being open. Okay, so now I'm ready to roll. I'm recording my initial volume here. This is my sodium thiosulfate in here, and I've got 1.4 mils. So in my table, I've had my 1.4 mils recorded. And I'm going to have my value that I end with to work out my titer value. So, once I'm ready, I pour my acid in, and I immediately start titrating. You don't need to swirl at this for this bit. When you do your vitamin C one, your values will be a lot smaller, so you have to be a bit more cautious. For this step, we've worked out that this is going to be about 30 mils, so we can actually go quite far until we start seeing some yellow forming where it's hitting, and it still isn't. If you're worried about that, put a bit of white paper underneath. Okay, it's starting to get some yellows. You can see the colour's fading, but it's still a brown. So we're going until we get it yellow. Yellow still has iodine in it, all right? So it's not too far. And you can see I'm doing it quite quickly because time will be one of our considerations on the day. But we're also trying to react that iodine before it evaporates. And I'm right-handed, so I find it easier. Well, I've taught myself to control that with my left hand while I swirl with my right. You might be the other way around. Okay, just get these out of the way so the video can see them easily. Now that it's a palish yellow, I add a little bit of starch indicator. We don't want to add it too early because it does make a complex with the iodine, and that complex has to be broken by the reaction. Now I want to go quite slowly. So I'm going to actually bring this up because it's hard for me to see easily there. And I'm looking for when it starts going colourless where the thiosulfate touches. When that happens, I've got to go really slowly. Alright, so again, good habit because I've poured something new in there, washed my walls down so all of my moles of thiosulfate are reacting. And now I'm being a bit more careful, waiting until I see it go colourless. It started to go colourless in there. I'm now getting to only probably a few drops away because I could see it go colourless and then the black came back. So I'm going to go quite slowly now. Okay, you see it go sort of fade and then come back. So we're one drop away. When it gets that real pale colour, note what your volume is just in case you slip here. You know it's not a titration value you can keep, but at least you know roughly where that end point would be. So at the moment, it's saying, for the one I'm using, 31.2. So I'm just going to remember that number in case I slip here and do too many drops. Which I did, actually. I slipped and I did 2 drops instead of 1. And it possibly went 1 drop too far. However, I'm still going to record it because it's gone to 31.3. So it hasn't really changed the volume much. So I've gone 31.3. And quickly, my brain is saying that that's 30.9. Sorry, 29.9. Is my first titration value. Now let's assume that's my average titer, because I want to do the last bit, which is the last bit of maths. Okay, so I'll move that away and hope nothing falls. Cool. let's assume that my average titer was 29. Sorry?
2.7.
Oh, I'm gonna go
0.9.
I'm gonna go with that one. I know that yours was 0.7, which is great, but I'm gonna go with that anyway. I know I overshot. Because I can't give you your maths, that'd be cheating. So, let's say that was our average titer. We need another equation for this one. This is the relationship between iodine and thiosulfate. So iodine reacts with 1 mole of iodine reacts with 2 moles of thiosulfate. The sodium's a spectator ion, so I've taken it out of the equation. And it makes iodide ions again. You can see why excess iodide isn't a problem now, because it's one of our products. Plus a thing called tetracyanate, which is not a chemical you need to know the name of. Just check, this side's got a -4 charge, this side's got a -4 charge. All the atoms balance, so we know it's balanced. Okay, so 2 times -2, 2 times -1 plus -2. So we're looking at a mole ratio here. We know that we had 1.51 times 10 to the -3 moles of this. Sorry, get my little grid because I like doing it. The concentration and volume are now irrelevant to these two, by the way. It's amount that matters. We know that because of this 2, 1 mole reacts with 2 moles. So 1.51 would react with 3.02. Okay, so I'm timesing by 2. That 2 there. And we get 3.02 times 10 to the -3 moles. I also know how much of this I've used. I said it's 29.9 mils, and we're assuming that was our average titer, 3 very close results. So that is 0.0299 litres. Someone's got a phone or calculator. Can they do that divided by that for me, please? I'm hoping it's around about 0.1.
Was divided by that.
Yeah, top one divided by the bottom one.
0.101.
Fantastic. So what we found is, yeah, it was approximately 0.1 moles per litre. It was exactly 0.101 moles per litre. Again, 3 significant figures only, because that's all we are precise to in these experiments. Because our volume was only 3, our amount was only 3. Okay. I think the group who did this one got about that as well.
Yeah, we got that.
Yeah.
Where has that second equation come from?
This one. So this is the reaction happening in here now. So when we set this up, we made iodine. That iodine is what the thiosulfate is reacting with. When you do your titration, some of that iodine will be used up by vitamin C. But I'll do another video for the vitamin C one, because there's another stage of calculations that I'll look at there. But yeah, so that is happening because this turned all of that into iodine. There's none of this left. Some of that's left over, but not this. Okay. Any other questions on that?